So today we're solving the majority elements simple Leetcode problem, array problem. I solved in using I solved it before using the brute force, and as you could see, it wasn't actually submitting because it's O n square and it's not expecting that. And then I solved outright with the solution, basically using a hash map and an object. So looping through here should be very straightforward. We could tackle this problem here with at least three solutions. Of course, we could have any other methods. I think we could do it with divide and conquer as well. Maybe I'm not really sure. But uh, the ones that I picked here, which are the most common, obviously, it's like the brute force, which didn't work as you could see previously. It's a quick out video with that in which the audio didn't come through when I was recording because I just forgot to connect the microphone basically. So the microphone wasn't connected and it didn't got the audio basically. That's why you just see the quick uh, failure there. It wasn't submitting because Leetcode doesn't expect a O(n) square solution for this problem. Um, so yeah, and then just did now with the hash map solution, which is very simple. Uh, Basically it's O(n) a linear solution. I started thinking here, it was like first thing that we like to do here is to think basically uh, what the problem states here, which is like all the problem says like loop through an array and find an element that shows up more than the average number of the array items, which is n divided by 2. So you have the element times have to show up greater than num's length divided by 2, which is the array length, basically. Um, and for that, what I've done, I was like, okay, let's create a map or hash map where we can loop through the array and we can kind of the store the numbers as they show up, and we can increment the numbers counting the times they appear and you update it dynamically. So basically, if I loop through 3 and 3 is not on the map, what we do, we add 3 to the map with a value 1. So 3 will become like, so the map will become 3, 1, 3, or 3, 1, as you wish. Um, what I'm doing is 3, 1, and then if we go 2, 1 on the second loop, and then on the third loop it will be something like this 3, 2 and 2, 1, right? That will be the result, and we have the map like this. So I was like, or I do a read this function or I create a comparison. So I decided to create an object basically which is called candidate, and it has index and value basically, and value. And then whenever I update uh, my map, okay, first I check, oh, it's not in the map. Then what I do is just like, okay, get the value. If it is in the map already, I'll get the value, and some one more occurrence for that specific item in the map. And then I'll check if my candidate value is greater than that or not, or I'll update. So whenever that happens, whenever I update, I think whenever the algorithm increments the counter for that specific array item during the loop, it will also update the candidate and return basically at the end the candidate value. Um, so that's the hash map solution basically. It's the ultimate solution for this problem. Whenever you can find something that requires a majority element in whatever that is, I think the Morse algorithm can can be helpful because what he states basically, I don't know what he states. Let's have a look. The Morse algorithm. What's that? Look what I found here. The actual paper, the source of the algorithm, uh, fast majority vote algorithm from J. Strother Moore. All right, and let's see what it says here. I already read it once, and I think what could basically uh, explain this quickly is just like um, his idea is that if each of the items in the array basically is a candidate, let's say each item in the array, like it's a candidate that will vote to a specific, uh, you know, have a specific preference. So let's say, for example, that candidate on index one will vote into party tree. Candidate on index two, index one, zero will vote in party three. Index one will vote in party two, and index two will vote in party three. So basically, what he says is that this each item of this array is a candidate. Basically, it's like this. Um, each value is a person here. He states that if each value here is someone and it's an election is like on a voting table and they're holding placards. That's so interesting in the way he puts it. I think the guy's a genius actually. Um, he says here, suppose a floor fight ensures and the delegates for each different persuasions begin to knock one another down with their placards. Suppose that each delegate who knocks a member of the opposition is simultaneously knocked down by his opponent. So basically, what we would have here is like these guys will be fighting. These guys are like holding placards, basically. I'm holding placards. I'm going to knock this guy out. Both. I'm going to knock this guy out. And we both gonna die, basically. We're gonna be knocked out by each other. And there will only be this guy here that will be left, basically. Oh, he'll be right. We never know. But he is here. He is outstanding. He survived the fight in the delegates floor, basically. Um, and that was his idea. So it's a genial idea. But how to represent that in an algorithm? So he describes that basically delegate in turn, keep in mind that a candidate and account K, candidate and account K, we go straight in the source birth. That's what we're doing. And then we're gonna say which is initialized to 0. So basically that's 0, right? Upon visiting each candidate, each delegate, actually. So I'm a delegate here. I'll say, hey, the chairman first determines which K is 0. If it is, chairman selects the delegate candidate as the new value of candidate and set case to 1. So if that happens, it's like, okay, I'm going through my first delegate here. I'm gonna say, hey, K will be 1 at this point here. So at the very first loop here, K will be 1, and candidate is what? It's 3, bro. You know, candidate is 3. You know what I'm saying? And what's going to happen then again is the chairman determines if K is 0, blah, 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 and the whether candidate is scanned. If then so, if not, then K is decremented by 1. So the next round will be the same thing here. We're going to go to the next round. Next iteration going to be 2. You're going to ask, hey, is candidate 3? What's your candidate? Oh, it's not 3. Okay, so let's decrement that. Then so it's going to be 0. K is going to be 0. All right, and then the candidate. What's going to happen to the candidate if uh, if not, then K is decremented by 1. Then we proceed to the next delegate. Let's go to the next delegate. We didn't change the candidate. When all delegates are processed, candidates majority exists. So let's go to the next delegate. Uh, it's 0 now, and the delegate is is obviously 3 because there's no delegate, there's no majority at this point, basically, right? So we leave it as 3, and then we go to the next candidate because we expect to have, if a majority exists. So then we go to the next candidate, basically, like, okay, is the next candidate 3? What's the next candidate? It's 3. Oh, okay. Is it equal? Is equal to the same candidate that we have? Yeah. So let's say it's 1, and then we find a majority, which is 3, basically, at this point. And let's use the other majority element here, for example, this one. How would that work, basically? Um, It'll be something like this. If candidate is uh, 2, we're gonna say, hey, candidate first loop is candidate is 2, and if let's get back to the paper. Um, can 0 yeah, I'll ask to the first candidate. Are you in favor of 2, mate? And candidate will be, yeah, I'm in favor of 2, bro. All right, no problem, bro. Thank you for your collaboration to this vote. And then we go into the next guy. Hey, are you in favor of 2, bro? Yeah, I'm totally in favor of 2, bro. You know what I'm saying? It's just, he's the best guy in the room. He's like extremely well articulated and all that. Okay, thank you. You don't need to do that. All this, feedback for me. Let's go to the next guy. And then the next guy will be, are you favorite to know, bro? 2 is being very annoying these days. He talks a lot. We need someone who's more straightforward. And then, he drinks a lot. I don't like that at all. Uh, okay then. So I think, you know, there's someone else who doesn't like this guy. So let's decrement it. Yeah. And then we go to the other guy. Oh, it's not as well. I don't like 2 as well, bro. I like 1. All right, no problem. And then we're gonna to the other guy. Hey, I really, really like 1, bro. Okay, so really like 1, and RK is 0. So basically, we're going to say that the candidate is 1 now, and this is going to be 1, basically. So how do we write that in terms of code, right? Um, Basically, what we're doing here is like, I have candidate, and which initializes 0, as he mentioned. Candidate is 0, and candidate actually new, and candidate and k is 0, and it's kind of undefined, something like that. You can just say let candidate, for example, and then as I iterate through the array, I'm gonna say, hey, is uh, if nums I equal uh, what actually we do here is just like, oh, right, candidate is equal um, if no nums y, basically, if nums y, if no candidate, uh, uh, candidate equal nums y, and k equal 1. That's the first thing here. Start the algorithm. Okay, now we started the algorithm. Let's tackle the next part of the problem, which is like, okay, the next item on the array, for example, we're gonna see if if nums I, do you like the candidate? Bro, I'm not very like this candidate here. So, um, okay then, if you don't like this candidate, actually, if you like this candidate, you're gonna say k plus plus, right? Uh, and if you don't like the candidate, you're gonna say, uh, I'm sorry, is equal candidate. You're gonna say k minus minus, right? And in between these guys here, what we need to say is we're gonna switch the candidate whenever if k is equal 0. If k is equal 0, so we're gonna say k plus plus, and if k is equal 0, what we do here, we're gonna say um, yeah, we need to know if when k is equal 0. Yeah, if we don't have any preference, you're gonna be the preference basically. So it's like if k is equal 0, uh, candidate is called nums y and k plus plus basically. Um, let's see in the order what this will run basically. So that's it basically. I think that will should do basically. It's not very clear for me, but I think we can start coding here. Is k equals 0? No. Is k nums greater? Is k nums y equal candidate? Yeah, it is the candidate. It's 2. So we're going to say k plus plus, okay, is going to be 2 now. And else, then 1 minus 1. Okay, now we're going to the other loop. If k is equal 0, yeah, candidate is equal 1. Then you go k plus plus. Yeah, I think that should be right, bro. Let's see. I equals 0. Uh, oh, it's a for loop. Yeah. Okay, okay. What did I miss here, mates? Da-da-da-da. So if 6 is the candidate, so it's going to be okay. K is equal 0. Candidate is go nums y. Hello? Is it a little fresh? Hello? Is it a little fresh? It's just like it wasn't else if because it was just a condition that couldn't, it's always like one nulling each other. So that's it basically. I think that's a quite simple solution, but and it's good that I found out that article. Anyways, thanks everyone. That's it for today. I'm ready to submit this video to YouTube. Please subscribe if you like it, and there's also my LinkedIn in the profile. I'll also leave this article that I found the link to it on the profile. And anyways, guys, thank you very much for joining and watching this video.